In this presentation, we want to take a look at how to analyze some data that turns out to be very common data for student projects. It really is an effective way to structure a project in many ways. So, and this analysis strategy is actually quite straightforward. So let's set the context for this a little bit. So let's say we're working. Let me see if I can weave these ideas in. So let's say we're working with a small group of moms, new moms, on infant care. And let's say we have as one of our items on an instrument an overall confidence rating on a 1 to 5 scale. And this is again it's very common actually. So what we do with a simple one group design, and the schematic is right here. You can see that it couldn't be more straightforward. We have a pre-measurement for participants on, in this case, infant care self-efficacy. They go through the program or the intervention, and then they do a post-measurement. So what we're doing, in effect, is measuring the same clients at 2 points in time, at a pre and a post. The other score here is a different score, so any positive number would be a gain of however many points. The first three, Sarah and Anne, for example, gained 3 points. Madeline didn't gain anything. She stayed the same. And then down at the bottom, we can see that Kelsey and Kenesha actually ended up losing a little ground. So these are matched scores. Actually, the logistics of a pre-post design are a little bit tricky. Lots of times, students end up not getting people to fill out a post test, or maybe they somehow missed a pre-test. It can be actually a real pain. So, a design that we often suggest is something called a retrospective post then pre-design. I won't get into it here, but it's really, for those of you who are interested, your instructor will be able to share some information about it. I certainly have information about it that I share readily. So it's actually turns out to be a popular design. Seems like I say that about all the designs, doesn't it? So anyway, it's once you get once, let's say our participants went through this, we have a score on a pre and a score on a post and then a difference test. So what we're wanting to do is to see if there's, and this would be the effect size here, we want to see if there's actually a significant effect size, and both practically and statistically significant. So we're gonna take a look at both. So one of the things, as you remember, that we want to do often is to graph our data. You can see we have a graph here, a simple bar graph that may show up here. There it is. So we have our mean pre and our mean post. The difference between the height of these two bars is actually the difference that we're interested in, where higher score is a better score, and then we just threw in the average score, the average change score, which would be a 1.57 value here. This isn't critically necessary, it's really this, but this gives you a sense a little bit about how many, on the average, how many points people managed to gain. So good. So to get to that graph, we actually end up, and I'm not going to do this, it's something you already know about. So we want to accumulate our means, and so we can click, you can see in this cell, we use the average function, and it's the average of B15 through B2 through B15, and then we did the same thing here, and the same thing here. And then it's just this simple to do the graph. We just click and highlight, go to insert, and go to column graph, and go to cluster column. I think this is going to give it to us. Let's take a look. Yep, it does, in fact. And then we can move the chart into a new sheet. So we can call this new chart. Ha! You guys now know that's what I'm going to do. And then click OK on that. So we really replicated our graph. We should have put down maybe new graph here, or we can. Chart and graph actually end up getting used interchangeably when we talk about statistical graphics. So I'm sorry for the confusion, but either one is fine. Actually, this is considerably less complicated to analyze than the two-group data. If you remember from those presentations, we actually took 3 presentations to work through to kind of do that. For this one, it's pretty straightforward. So we're going to treat these as continuous. It's probably a little teensy bit of a stretch, but we're going to do it anyway. So we're going to do a mean difference, and then we want to do a standardized mean difference, which is something I'm going to show you how to do. So just real quickly, the mean difference is simply the mean post-test. The mean post-test value of 3.64 minus the mean pre-test value of 0.207. So on a 5-point scale, on the average, people gained a 1.5. So I'm not sure that has a lot of meaning, much like the scored values in our two-group presentations. What's going to have more meaning would be the standardized mean difference, or the Cohen's d value. So in order to get that value, we actually have to do a statistical test, and so we go to our data tab, and we go into data analysis. And the test that we're interested in doing is the paired 2 samples for means test. So click OK, and we'll click on the first array of data, and I'm going to do the post first. You don't have to, but it actually changes the sign. It's actually kind of interesting to do it this way, and then we'll go in and do the pre. So we're going to do the post and the pre. The order, honestly, trust me on this, doesn't matter. And we're going to have it put in a new worksheet, and we could call it a paired. You can actually type in a tab value for it, and you can see it'll pop up, and we have it already here, but let's click OK. So there we go. We get our paired samples t-test. Let's format our cells. Let's set them at two decimal places, and then we can sort of take a look at it from there. So we end up with we end up with these data. Actually, I was trying to see if it gives us the actual difference. It does not. But what it does give us is the p-value. I'm going to switch over to this. This is the presentation. I think I have it a little differently. I'm going to switch over here. So I guess it doesn't look that much different. But anyway, we end up with a two-tail p-value of 0.004, which is, as we know, less than 0.05, if you'll remember our conversation prior. And so we would consider this difference to be a statistically significant difference. We also want to ask the question, as you know, is it practically significant? So our effect size here, which is a Cohen's d, incidentally, I should have typed that in, but it is the effect size. Cohen's d is 0.93. So let's see how that gets computed. And this is actually the formula for that. So d in this case would be our t value of 3.465 divided by the square root of n, and our number of observations is 14. And it's 14 for both groups because they're paired. So they're matched scores. So if you do that little simple math, if you worked it out in with your calculator, you would end up with an effect size of 0.93. Just to repeat, we know that Cohen's d value of 0.2 is small, 0.5 is medium, 0.8 is large, and 1.0 would be considered to be very large. So this is a substantive effect size, kind of between large and very large at 0.93. We would be happy with this. This is a discernible effect between the two measurement periods. So what we have is a difference here that is both statistically significant and practically significant, and we're happy about that. And that's the process. We just went through the process to do that. So, and to just suggest one more time, this is very popular as a design. So if you run into a project that might require assigning people to a group and doing a pretest and then doing something with them and then actually doing a post-assessment, consider this design. It's not a real strong design from ruling out other factors, but it's a practical design. And the retrospective post and pre aspect of it is actually quite compelling. I've had my students who did them really thought it was terrific. So that's our presentation on paired sample t-test, one group pre-post data analysis using Excel.